units. So in that particular first topic is voltage and current sources. So in this particular voltage and current sources, I will start with the voltage source. Just look at the document here. Voltage source. Actually, the voltage source is we can classify it into ideal voltage source and practical voltage source. Of course, we have a dependent and independent sources are there. First, I will make the classification first, then I will explain one by one. Okay, so first look at here. The sources are classified into two types. Initially, that sources are independent sources and dependent sources. Okay, independent and dependent sources. So in the independent sources, we have a voltage source and we have a current source. Here also we have a voltage source and depends upon the current. Second, voltage source depends on voltage, and then current source depends on current, and current source depend on voltage. Okay, I will explain in detail in the further slides. Just idea about. So independent and dependent. Here also we are considered two parts, ideal and practical. Is it okay? So with help of this idea is enough to moving further. First I will start with the voltage source ideal case. What is mean by ideal? Means there is no in the ideal source, see here, the terminal voltage remains same. So just look at this particular figure. In this particular figure, for example, I apply 10 volt here. Not apply the battery. For example, the battery is a source I connected here. If it is 10 volt, I'm consider this is ideal. The terminal voltage is also 10 volt. That means there is no drop across these terminals, in between the terminals and source. So that is the ideal case. That is the first point you need to remember. After that, in other words, voltage source should be ideal. It is a fixed terminal even though current drawn may be vary. So what the meaning here? For example, I connected the load resistance. So in this particular resistance is variable. If I connected 1 ohm resistance, if I am applying the 10 volt, what is the current flowing through this particular circuit is I is equal to V by R. What is a V? 10. What is a R? 1. So 10 amperes is okay. 10 amperes. So if I am increasing this resistance to 10 ohms, so if it is 1 ohm resistance, what is the expected voltage here? 10 volt. If it is 10 ohms, what is the current? I is equal to V by R. So that is a 10 by 10, 1 ampere. But what is the current available at the resistance terminal is 10 volt. It is okay. So the ideal voltage source current is constant irrespective of the load connected. That is a point here explaining. Maybe that is a resistance or impedance. If it is AC, it is impedance. In case of DC, it is a resistance. So the DC voltage source is represented by this particular symbol, and AC voltage source is represented by this particular symbol. Okay. Then we are moving to the characteristics. What exactly the characteristics of the ideal voltage source? Ideal voltage source, I'm reference is a current in the x-axis, y-axis is a voltage. Just now I gave the example to you. That example is, if the current is 1 ampere the voltage will be the supply voltage. That is what I have taken the voltage here 10 volt. The 10 volt is appear here. If it is 2 amperes, the voltage across the load is 10 volt only. It is 3 amperes, 10 volt only. It is a 4 amperes, 10 volt only. What exactly here? The voltage is constant irrespective of the current we are applying, that is a load you are connected. So that is a characteristics. This is the characteristics of the ideal voltage source. I hope you understand. So what exactly the VT, VS, IL, the terms I am using this particular concept. The VT is a terminal voltage. See here, this is a VT, that is a terminal voltage, and then VS is a source voltage, IL is a load current flowing through the circuit. Okay, then we are moving to the practical voltage source. So ideally, ideal voltage source, it is a source present ideally theoretically, but practically it is not possible. So but practical sources are there. What the difference between the practical and ideal voltage source? Just look at here. In ideal voltage source is not practically possible. Just now I mentioned there is no source which can maintain terminal voltage constant. If it is for example, if you take some battery, that is a cell, just measure their nameplate details. They mention that it is a 3.5 volt. With help of your what we call multimeter, we can measure this particular voltage. It is not exactly 3.5 volt always. Maybe some difference will be there, the mentioned voltage and then apparent voltage, because of the internal resistance present in the voltage source, that is present in the practical voltage sources. Okay, next, when terminals are short circuited, okay, short circuited, if could be, so it would be mean that it can be supply infinity amount of power to the short circuit in the practical voltage source. It is not possible, hence ideal voltage sources does not exist. Just I will give the explanation here. Just see here, if it is an ideal voltage source, I am short circuiting these two terminals, I mean short circuited. So ideal voltage source is the capability of supplying the infinity of power. Power is infinity. It is possible in ideal. Practically it is not possible. That is the main difference here. Okay, if it is short circuited practical voltage source, the power is not infinity. It is not able to supply complete power. Total entire battery cell going to be discharged. Okay. Next, practical voltage source can be consist of a ideal voltage source in series with impedance. This is a very important. If it is DC circuit, the resistance will be in series. If it is AC circuit, the impedance will be in series. That is a major difference here. So just small difference in this case. Ideal voltage source connected with the small internal resistance. I am not mentioning that it is a small or large internal resistances. I will give the explanation for that. Just look at here. The ideal voltage source, the practical voltage source, some resistance connected to the ideal voltage source, then it forms the practical voltage source. This is the representation for practical voltage sources. Okay, so here the characteristics of ideal and practical voltage. The terminology I am using here: RS is a source resistance, ZS is a source impedance, VS is a source voltage, VS is a source voltage in both the cases, both AC and DC cases. Here the characteristics, practical voltage source characteristics. If current I am taking the reference, if voltage I am taking the reference, both the graphs are similar. The reference is changing, the graph orientation is also changes. So if I am increasing the current, what will happen here? Due to the internal resistance of the voltage source, the voltage drop appears, the voltage will be decreases, not more, just somewhat decreases. So this is the characteristics of practical voltage source. So I hope you understand. So what exactly the ideal and practical voltage sources? One more important point here I am mentioning. If it is ideal voltage source, the internal resistance is 0. If it is ideal voltage source, just note down it, make one important point here. If it is ideal voltage source, the internal resistance of the ideal voltage source is 0. If it is practical voltage source, very small internal resistance will be present. Very small internal resistance will be present. So these are the 2 points are important. So in this particular concept, okay. Next we are moving to the next ideal current source. In the ideal current source, see here, a source that supplies a constant current to the load even if it is impedance is varying. Just take it. I will take the one example. Current source, I am consider this is 10 amperes. Okay, I'm connected to the 10 ohms impedance or resistance, variable resistance. So initially I'm connected to 1 ohm. What about the current flowing through this particular impedance is 10 amperes only. Okay, because it is an independent source. So the voltage will be V is equal to IR. What is the current 10 into resistance 1? What is the voltage across impedance is 10 volt. Just look at the example here. Second case, V is equal to IR. I am changing the resistance to 10 ohm. Okay, if it is I am changing to 10 ohm resistance, the current 10 into 10. What is the voltage here? 100 volt. So you got the idea. So if I am increasing the resistance, voltage will be increases, voltage drop will be increases, but the current supplied to the from the source is constant. That's why it is a independent source, constant current source. Okay. The characteristics will be like that. Impedance, just now I took the example. The impedance will be 1 ohm. What is the current? 10 amperes. Impedance will be 10 ohms. What is the current? 10 amperes. Impedance will be 100 ohms. What is the current? 10 amperes. For example, I am open circuited this particular voltage source. What expected your current? The open circuited means that the impedance is equal to infinity. The impedance is equal to infinity. V is equal to I into infinity. Resistance impedance is infinity. Voltage will be infinity. What about your expected current? The voltage will be infinity. Definitely current will be 0. So open circuit, there is no possibility of current flowing through this. You should understand that. I will explain in detail further concepts. That is a what happened for the open circuit and short circuit conditions in the next video, next future further videos. I hope that it is clear. Next, but one interesting factor here, if it is current source is present, you are not at all opening the load. It is not doing practically. Of course, the current sources are practically only. The example will be the solar panel is an example for practical current source. I mean current source example. Okay, until unless it is required, they won't design the practical current sources, especially voltage sources they design. Okay, practical current source. The practical current source here, just look at the diagram here. Ideal current source connected parallel with the impedance, it is called as a parallel practical current source. See here, ideal current source cannot exist. Yes, of course. And then obviously there are cannot current sources can supply constant current even if terminal voltages are open circuit. Okay, just now I gave the example to you. The reason why actually sources does not work an ideal current source in internal impedance is not infinity. Okay, a practical current source is represented by symbol shown in the figure. This is a practical current source. So the source impedance ZS is put in parallel with the ideal current source. So that is about the ideal current source. Practical current source means that ideal current source parallel with the impedance. You call it as a practical current source. The characteristics will be like that. If it is I am applying the 10 amperes, not all the 10 amperes current, all the current is not flowing through the particular impedance. Maybe 9 amperes is flowing, some 1 ampere current will be flowing here. If it is impedance is increases, the current flowing here decreases, the current flowing through the impedance element will be increases. What happened exactly? The small difference of the current from the ideal and practical cases. This is about the practical current source. So one more important point here, ideal current source, the internal resistance is infinity, and practical current source internal impedance will be high. It is a very high resistance or high impedance will be present. Okay, next we are moving to the, okay, we have completed the explanation about this once again. Okay, look at the problems on source transformation technique. The problems on source transformation technique exactly here. First I will give the explanation how to convert the practical voltage source into, just look at here, how to convert the voltage source to current source to voltage source. I will take the voltage source, the practical voltage source. The voltage will be here 10 volt, resistance is 1 ohm. Okay, so I want to convert this voltage source into current source. You know current source symbol, we had a discussion on that. This current source symbol, the current source I in parallel with the resistance or impedance R. So you know Ohm's law. What is the Ohm's law is saying? I is equal to V by R. What is a V? 10 volt. What is a R? 1 ohm. So what is the current? 10 amperes. We can place it here, current is 10 amperes. What is the resistance available here? 1 ohm. That resistance we can replace it in parallel. This is a way to convert the voltage source into current source. I hope it is clear how to convert the voltage source to current source. Next, we'll take the another example. The example is like that. If I am having the current source is 10 amperes, the current source will be 10 amperes, impedance will be 1 ohm. The same example, I need to convert this current source into voltage source. You know how voltage source will be represented? Resistance in series with the voltage, you know, A and B terminals. So resistance here the voltage formula from the Ohm's law, V is equal to IR. What is the R value? R value is a 1, I value is a 10 into 1, that is a 10 volt. So what the voltage replaced here? 10 volt. What is the resistance? The resistance is present here 1 ohm. That resistance will be connected here 1 ohm. Is it okay? So this is a way to convert the voltage source to current source to voltage source. Now we are moving to the problems. So problems on voltage source to current source to voltage, that is a source transformation technique. Okay, this is a very interesting one concept. That is the first problem I'm dealing with here. Simplify the network into one voltage source in series with the resistance. It is clear? Using source transformation technique. So using source transformation technique, so convert total entire circuit into single voltage source in series with the resistance. Look at the circuit present here. You know this is a voltage source. This is possible to convert into current source. This is a voltage source possible to convert into current source. This is a voltage source possible to convert into current source. This is a voltage source possible to convert into current source. You got the concept what I am explaining here? If it is this particular structure is present, that is a practical voltage source, it is a possibility is there to convert into current sources. First of all I am converting these two. Okay, how to convert here? See here. You know I1, I am consider this the I1 What is the formula from the previous explanation from the Ohm's law? I is equal to V by R. What is a V8? What is a R2? What is the current? 4 amperes. It is fine. Next, I am consider this is a I2. How to find out I2 current? I2 is equal to V by R. What is a V here? 6 volt. What is the resistance? 1. Okay, it is a 6 amperes. So once you got the voltage source equivalent to current source, you know how to represent it. Current source 4 amperes in parallel with the, what is the resistance availability here? 2 ohms. The 2 ohms connected in parallel. Second case, 6 amperes connected parallel with 1 ohm resistance, because 1 ohm is present in series with the voltage source. So this is about the first step. And the second step here, these two voltage source convert into current source. Okay, let me explain here. What is the voltage V3? The voltage V3 here, 6 volt. I am consider this is I3 current. Current is I3. This is current is I4. I3 is equal to V3 by R. That is a 3 amperes. I4 is equal to V3 by 1. That is a 3 amperes. It is okay. Once you got the values of that, then we are connecting current source in parallel with the resistance. Current source in parallel with the resistance. That is a 3 amperes, as well as 3 amperes, 2 ohm and 1 ohm based on the resistance given in the circuit. Okay, this is a simplified version. After that, you know, this current is towards the node, particular node. This current is towards the particular node. Both are additive. So that is a 10 amperes. This 2 ohm, 6 ohm, this 2 ohm and 1 ohm connected in parallel. Both are connected in parallel. You can know R1 into R2 by R1 plus R2. That is a formula for R equivalent whenever it is connected in parallel. I am going to give the derivation for the next videos. So just remember that formula. See here. So when our 4 and 6 are connected, current flowing towards the node, both are same direction. So 10 amperes current is, total current is 10 amperes. And one more thing, this particular 3 amperes, the flowing in the same direction, right? Both the same direction arrows are, we can add both the currents. That is a 3 plus 3 is 6 amperes. Okay, so that's why I am replacing this 10 amperes and 6 amperes by single source, current source. Now you got the idea. These two are connected in parallel, these two are connected in parallel. So by using the parallel resistance formula, R equivalent is equal to R1 into R2 by R1 plus R2. That is a 2 into 1 by 2 plus 1, that is a 0.66 amperes. As well as this 2 and 1 connected in parallel, 2 and 1 connected in parallel, 2 into 1 by 2 plus 1, that is a 0.66 amperes. Now these two are current source, practical current source. These two are practical current source. Okay, you know how to convert this current source into voltage source. How it is, you know, Ohm's law, V is equal to IR. I is 10, 0.6, that is a 6.6 volt. VT is equal to I into R, 6 into 0.66, that is a 3.96 ohms. You know, I into R. Now how to replace this particular circuit? The current voltage source, this current source and resistance convert into voltage source. What is the resistance present here? That is connected in series. As well as here the voltage connected, the resistance what present here 0.6 is connected. Okay, now this is a positive and negative terminal. Once you are applying KVL, actually KVL is the next topic. Just common sense, apply the common sense here. This positive terminal, this is a negative terminal. Whenever positive and negative terminals are present, both the polarities are added. The potentials are added. So this is a 6.6, this is a 3.96. Both are added, that is equal to 10.56. These two are series, right? So the both are added, 1.32. This is about the solution, about the first problem. Is it okay? How to use the source transformation technique to simplify the circuit? Okay, this is about the explanation about the first problem. We are moving to the second problem. The second problem here, using the source transformation, convert circuit shown in the figure into single voltage source in series with the resistance. Okay, it is also simple. First of all, we are going to do that. This 2 ohm and 10 volt, this particular 2 ohm and 10 ohms I'm going to convert into current source. Why I'm doing that? This is the current source, this is the current source. Okay, for example, if I'm converting this is a current source, all the current directions are out towards the node, you can add it all the currents. It is a simple way to do the problem. Otherwise you are converting to voltage source, of course you will get the solution, but it is going to be complicated. So while you are doing the problem, just keep it in mind whether it is converting to voltage source to current or current to voltage source. First decide it based on the circuit diagram, not blindly convert voltage to current to voltage source as you require. Okay, what is the formula for current? I is equal to V by R. What is a V? 10 R is 2, that is a 5 ohms. You know how to replace the circuit. This total entire remaining circuit is common. This is the 5 amperes, right? What is the resistance present here in series with 2 ohm, right? The 2 ohm present here. 2 ohm present here. Now this is the circuit. This 5 amperes income towards the node is nothing but a total entire. This is the node. So once you are applying actually KCL concept, so all the currents are incoming. 5 plus 5, 10, 10 plus 10, 20. What is the total current? 20. So 5 plus 5 plus 10, 20 amperes. Next 2 ohms, 2 ohms, 3 ohms, 2 ohms, 4, 1 ohm. All are connected in parallel. So if all are connected in, just replace here all the current sources with the one current source. All are connected in parallel. You know how to calculate the parallel resistance. If you don't know, I will give the derivation for the next video. It is our part of the syllabus. So what is the formula for parallel resistance? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5. So that is R equivalent is equal to 0.352 volt. So finally you will get 20 amperes parallel with 0.352 volt. But you want the voltage source in series with the resistance, so that's why I need to convert this current source into voltage source. So V is equal to IR, I is 20, R is 0.352, then you will get 7.04 volt. Okay, so this is about the final solution about the problem. I hope that you got the idea about the concept. So we completed our first topic, voltage and current sources. In the next video we are moving to the next topic, that is the resistors connected in series and parallel. So thank you for watching, and then bye.